Hi everyone, hello. My name is Eran Kinsbruner, and I welcome you to my session at DevOps Pro Europe. I am a DevOps evangelist and a global head of product marketing at Lightrun, which is a dynamic developer observability platform. We'll talk about it if time permits last in the session. But in my session today, I don't have too much time, but I'll try to explain why troubleshooting distributed workloads and complex architectures is so complex and so hard, but it can be made more possible and easier when you shift left observability, when you employ a new method on top of your APM and logging infrastructure and tools. So developers, as we say, are much more connected to the applications that they actually developed that are running, whether it's in production, in CI, QA, staging, doesn't matter. But most importantly, if they are running in production and you have an issue, this is where all of what I'm going to talk about becomes very critical, very complicated, and time in this case is the most critical parameter or value that organizations should care about. So let me start by highlighting a bit of the pain that we see today. Most of the organizations today, if you read surveys from the CNCF or DevOps DORA or other surveys within the marketplace, we know that the majority of organizations are running containerized applications, distributed workloads, microservices, serverless, all of these modern type of applications. With that aside, there are still organizations that are doing a mix of deployments. We see organizations, mostly large enterprises, that are still, have much more newer and modern applications based on microservices, but they have legacy applications that are not retired yet, and they need to support them. I will talk a bit about this nuance between the legacy and the new and modern architectures as we dive deeper into this session. But a bit about the pain. So if you look today at, we are in a DevOps conference. So, right, you have a DevOps organizations. It can be a squad of different practitioners with QA, with developers, with other DevOps engineering, product owners. It doesn't matter. At the end of the day, what does matter is that the development team, the engineering team, is using a whole set of different tools than what the operational guys that are, in the shift right equation uses. So just giving you an example, the operational guys are using tools for logging and APM alerts, right? Splunk, Datadog, Dynatrace, and the likes. Developers live within their IDEs, IntelliJ, PyCharm, and the likes, okay? GitLab, GitHub, okay? So there is already, by definition, a disconnection, and this is a natural one. This is not a bad thing, right? This is the reality. It's based on skill set, it's based on objectives and job that needs to be done. The developers, by definition, are using different tools than what the ops guys are using for their daily job. But this reality, which is not bad, but this is what it is, causes some reactive rather than proactive approach to when things go down, when things are not performing as they should in production or even in pre-production environments. And this causes, when things like that happen, for the developers, as you see on the most bottom bullet here, developers are disconnected from their live applications. That's the bottom line, right? Because if something happens in production, the first guys that are getting alerted are the ops guys. They are getting the alerts from the Dynatrace and the APM tools. And this is a bit late in the game, because when you need to troubleshoot something, you then, okay, what do I do? The ops guys might not have enough telemetry data and insights into what causes the issue. This is where they turn back to the developers. The developers find that they don't have enough logs or insights into what is happening, so they need to add more logs, right? And this drives a new CI/CD pipeline, and this is very inefficient, very slow, and unfortunately also very expensive. So this is, the reality, and what we're going to talk about in this session is how, by shifting left observability, by empowering developers to be more connected to what's happening in the distributed workloads, in the remote environments from their IDEs, from the IntelliJs and VS Code of the world, they can react much faster. And just making sure that it's clear, the developers are not taking the dinner, lunch, breakfast and job of the ops guys. The ops guys have a very critical and important job, but this disconnection makes both teams miserable and less productive. So with a new approach that I'm going to present to you in this session, you will understand how the collaboration and the empowerment of both teams, by the way, can help the organization to react much faster to production incidents or pre-production incidents. And by that, if anyone is following me on LinkedIn in this session, I've just ran 2.5 weeks ago a live webinar with Google Dora and Priceline, one of our customers. And what Google Dora is all about, right, is the productivity metrics, the MTTR, the failure rates, the percentage of failure rates, and these kind of things. So what I'm going to describe here is also something that contributes to improvement in developer productivity, MTTR, and the likes. So what I am seeing and what Lightrun sees from a troubleshooting perspective as key use cases, which are very challenging, are the following 7. There are 8 here. I will just touch on 7 and I will leave one, which is not a troubleshooting use case. It's more kind of an optimization use case. Okay. The first one is troubleshooting Kubernetes clusters. We know how hard it is to troubleshoot Kubernetes environment, remote and distributed, especially when the scale is massive. Not to mention when you are shifting towards serverless, like Lambda functions from AWS and Google functions from Google and the likes, right? So serverless is even more complicated, and I will touch a bit about why each of these use cases is so complicated. I mentioned earlier that our organizations have also done an event recently with M&T Bank. M&T Bank told the market that they are like a museum, right? They have applications from different ages, from different eras. Some of them are very legacy and monolithic, and some of them are very modern and microservices oriented, which means they need to tackle both types of environments. The next thing, or the use case that you need to troubleshoot, is CVEs, and how do you prioritize them? CVEs, for those of you online that are not familiar, are security vulnerabilities which are attributed to open source libraries, and we are all using open source libraries. Even if you're not using, you have heard about Log4Shell, Log4j, and all the very famous, severe and critical vulnerabilities. Being able to understand which CVEs impacts which environment and which client of yours is a challenge that can take you a lot of time. So that's another use case. A fifth use case that is how to troubleshoot, and again, I'm going to explain why, is code flow investigation using feature flags. Even within Lightrun, when we are building our SaaS environment, our SaaS platform for troubleshooting, right, we have different features behind different feature flags. So think about an incident which is very specific to only a feature which is now enabled, but the other environments are not relevant. How do you troubleshoot only this isolated environment in production without really replicating and doing every setup from scratch? From a development standpoint, it's very, very hard. Okay, so that's also a challenge. That it's not just, by the way, everything that you see on the screen, it's not something that Eran is inventing. These are live, real life use cases and challenges that we are hearing from existing customers of Lightrun, but also from market practitioners. I'll jump to number 7 because I told you the optimization is a bit different, and I'll talk about CI/CD debugging, right? If something fails within your CI pipeline, whether you're running GitHub Actions or other CI pipeline, what causes that? You need to troubleshoot. And basically, when you're using CI, you don't put any logs or breakpoints within the flow. So being able to understand whether it's a failed test, a bug in the test, a bug in the software, it's very, very hard to pinpoint. And that's also something that slows down the troubleshooting and is a pain point for developers. Last but not least is the performance issues. We know how important it is to have a production environment that really functions and works as it should. When you have a performance degradation, being able to understand what is the anomaly that causes that, what is the root cause, is very, very hard and very, very complicated. Troubleshooting that is a nightmare. So the eighth use case, which is number 6, is the log optimization. And this is where I actually told you in the previous slide that when something happens, developers are either adding proactively logs during the development stage, just in case. That's the word, just in case, right? And this is really causing a huge amount of cost to the cloud bills that the engineering team is paying. Being able to minimize the static logs that you have within your code, the ones that you put in Datadog and the likes, logs.io, is very, very critical, especially when we are in a very economic stretch for the past few years, right? So being able to optimize the logs that you are using only to the logs that are very, very effective, the ones that you're really going to use, is a new practice that organizations need to employ. So they reduces the cost of troubleshooting, and B, are being much more agile, if you like, to add telemetry data only when and where they need when something breaks. And don't just take my word for it. This is a survey that was done quite recently by Microsoft. And what Microsoft is telling us, maybe it's not a huge surprise, but this is scientific data, okay? That's real data coming from Microsoft, is that the majority of the RCA, when something breaks, like I've shown you in this previous slide, when something breaks in a Kubernetes cluster environment, when something breaks in a serverless function, or other out of these 8 use cases, 7.5, right? The RCA statistically shows that the majority is related to code-related bugs. And people would say, duh, right? We write software, we have bugs. No, but if you look at what you see here in different colors, there can be so many different reasons to why things breaks, why incidents happen. It can be a dependency, it can be infrastructure or network, it can be deployment, and can be configuration and stuff like that. So RCA category shows that code-related bugs, software quality, if you like, lack of testing, I don't know, human error, these are the main root cause for issues. But the mitigation, is very, very important either, because the majority of organizations, when something happens, is to either do a rollback or to do infrastructure change. Both are very, very timely and very, very costly. Okay, think about to do a rollback and do a full CI/CD pipeline with all the testing, regression, and the likes, and especially when it's in production, can be a huge, huge hassle for the entire team, not just for developers, right? So code-related bugs that leads to rollbacks and infrastructure changes can be very, very complicated. And if you look at what impacts, these code bugs and what is happening from a total time or time to deliver and time to mitigate, you can see here still from the same research by Microsoft that the code-related bugs, like I mentioned in the previous slide, are the ones that are taking the longest from a time to mitigate. You see TTM here, time to mitigate issues that are related to either code bugs and dependencies, mostly code bugs, is the highest and the longest that it takes. Okay, with that in mind, let's understand why code-related bugs takes so long to fix in these different use cases that I've talked about. And starting with Kubernetes clusters, right? We know that Kubernetes clusters are at high scale, and you need, as a developer, usually you don't have, right? But to troubleshoot issues that are happening in a service that is deployed in, I don't know how many replicas and how many pods in production, you need, first and foremost, you need access to this environment. As a developer sitting at your home or your office, usually it's going to be very, very restricted and very hard to get access to this environment. So logging and obtaining telemetry from these environments is tedious, costly. Getting remote access is usually not approved by CISOs, by the security guys, and okay, you found something, updating the code in production is obviously not recommended. And when you need the access, sometimes you also need to employ port forwarding and special permissions. It is also a pain for IT and engineering by definition. So you can understand that something when it's breaking in production, you have seen what Microsoft is saying, but even if you do have the time and you do have, I don't know, the understanding of what happened, being able to troubleshoot it in such a remote environment is very, very complicated. If that is not enough, then you look at what is happening with serverless, right? You have serverless functions that are available from both from actually all cloud providers, starting from Google, AWS, and Microsoft Azure Cloud. They all provide you the technology and the infrastructure to build serverless architecture, serverless applications, which are by definition very, very lean. You just build the code, and the cloud providers actually provide you with the infrastructure that you need and the scale that you need to run this environment. But again, it's in the definition of serverless. It's the code is running locally, but everything else is being populated by the cloud provider. So it's very difficult to debug and analyze what's happening locally in your IDE, right? As a developer, understanding the resources that are impacting the issues is also not under your control as a developer. Again, talking about locally versus running in the cloud. And we know, I won't read you the full slide, but we know that by definition, serverless functions live for a very, very short amount of time. Sometimes it's just 1 or 2 minutes, sometimes it's even less. So even if you know what is happening, you don't have that much time because the runtime of such a function is very short. Okay, so I think I've scared you enough, right? Kubernetes cluster debugging, serverless architecture debugging, it's very, very hard. And these are the major architectures that organizations are using today to deploy and build modern applications. As I mentioned earlier, many organizations do still have a mix of legacy and monolithic. I don't want to read you the full slide because we don't have time, but I just want to give you 1 or 2 points about why it's so complicated today when you are dealing with incidents in a monolithic application. Just building such a huge monster, you think about a bank, right? I mentioned earlier M&T in my one of my webinars, right? Just building a new version of such a monolithic architecture is very, very long, not to mention adding new logs, running a full CI/CD or a full cycle of testing before you deploy it, right? So many dependencies and long restart time. These are things that are by definition comes with the definition of a monolithic architecture. This is, by the way, why many organizations neglected or moved away from monolithic to serverless and cloud native architecture. But when you do have these applications, and even though there are not that many, depending on the organization maturity, it's also quite hard and challenging. Sometimes it's even harder than Kubernetes clusters, because with Kubernetes clusters, at least you're dealing with more modern and very pinpointed pods and environments. Here you have the full-blown application with all of its dependencies that you need to build and analyze when you have an incident. I spoke a bit about the CVEs. I'll just say a word. Everyone today, including my engineering team, is using SCA and SAS tool to scan. Sometimes it's a part of the criteria when you're building a new version, when you're building a new iteration of software, right? You need to show that you don't have any P1 or critical CVEs, security vulnerabilities that you have within your open source libraries that you're relying on. But as I mentioned in the intro during this session, you as a developer think about a dashboard that consists of, I don't know, 20, 60, 80, I don't know, depending on the size of your application. You have dozens of CVEs. Where do you get started? How do you know which of those are impacting your environment in production and which users are impacted? Usually you have no idea, because for that you need to understand what is running in which environment. Okay, so troubleshooting CVEs in production to determine which are impacting which users in which environment with which feature flags. It's a very, very difficult pain. And talking about feature flags, again, I mentioned it earlier, being able to understand a specific environment, and most importantly, to replicate it, to understand which environment with which characteristics is being impacted by the incident, is very, very hard and also very, very complicated, because you're dealing with very specific data. Sometimes it's customer data, sometimes it's production data that you can simply not create or recreate in your pre-prod environment. So debugging feature flags in production is another challenge, another pain that we keep hearing in the marketplace. And I have the full faith, and I truly support, this is the best modern agile way to build software, using feature flags, progressive delivery. This is the way to go, right? But keep in mind that also it's the way to go with serverless and Kubernetes clusters, but it comes with a toll. It comes with some challenges, because when something breaks, you need to understand how you're going to approach it. You need to understand what or when the ops guys start and when the development team begins, because or takes it away from them. So it's all in sync, and kind of dev complements ops in a very efficient way. I will not spend much time on the cost optimization, but I mentioned earlier, and this is taken from the FinOps organization, empowering engineering. I just focus on this response. Empowering engineering to take action on cloud cost. This is one of the biggest challenges that FinOps believes in. And it makes sense, right? Engineering usually have the biggest budget within the organization, and with that, they not always look at how much really a new log line, a new deployment, I don't know, a new amount of cloud computing actually costs them, because they're not really seeing the report or the purchase order. They just care about building the software the best they can, and this is their job. But as economics become a critical pain, with like FinOps shifting also left towards the engineering, it's important to allow engineering to have visibility and accountability into how much they spend to build the software, because there is always a better way to build the software when you take also cost into consideration, and specifically with regards to the log everything and analyze data that I mentioned earlier, right? Being able to debug in different ways and only put logs when and where you need during the development phase, knowing that you can always get back to this code in production, is a new mindset, a new shift in optimization and productivity that I'm going to talk about in the coming minutes. Last but not least is the challenge around CI/CD debugging. I mentioned earlier, something breaks in your CI/CD. How do you understand what's going on? Is it a test issue? It's a feature that is breaking. It's a feature flag. It's a dependency, code bug. You have seen what Microsoft is saying, but being able to troubleshoot within the CI is also a very big challenge, again, because you don't have all the telemetry, and the developers usually are flooded with so many things going on, which makes it very, very hard. Performance issues, I'm going to show you very soon a demo, because everything that I've just said will become even more clear when you see it's live. You understand all the nuances of troubleshooting reactively, as a response to something that happens, versus doing it on demand when you need only and where you need. Okay, so dealing with anomalies and performance issues is also a huge pain, and it's also a pain for the business, because when something is not performing as it should, or you have discrepancies in data in production, like user login failures for specific users, it's very hard for you to manage the business, and the business actually is being impacted in the bottom line. When I talk about shifting left observability, and I'm going to show you soon what I mean by that, it's also important to understand that there is a feedback loop. Okay, we always, like in the past decade, we were always familiar with this DevOps endless infinite loop, right? building, debugging, deploying, all this shift left and shift right, everyone was talking about, right? But no one was talking about the real feedback loop, which makes everything much more efficient, okay? And I won't touch on platform engineering and the tool stack. I'm just going to talk about the feedback here, okay? When you're dealing with a production issue that happens in a specific environment, again, doesn't matter if it's Kubernetes, serverless, or legacy monolithic, or whatever, something happens, right? You did all the work, troubleshooted it. How much time it took you, I'll put it aside right now, but you fixed it. Are you able to share this feedback loop of the root cause? We talked about earlier, the root cause can be dependency, can be code-related bugs, can be infrastructure, whatever. Are you sure that you sent also the feedback back to your testing team so they build modern and new up-to-date regression tests? Right? We know the test pyramid. I actually wrote books about continuous testing, but this is much more than continuous testing. It's about closing the loop. We talked about ops and dev, being more connected by shifting left observability, but all this feedback also needs to be shifted left towards the testers. So this is not being kind of a recurring procedure, a recurring event in the future. So once you solve the issue, regardless of the method, please make sure that testing also receive the feedback, the root cause analysis, and where in the code the issue failed, just so they know which kind of test cases they need to build, modify, add, so this is not repeating in future iterations. After I gave you all these scary use cases and scenarios, let me introduce to you what I mean by shifting left observability or observability-driven development. When I talk about shifting left observability, I'm not disconnecting dev and ops. I'm actually really connecting them one to another, but in a much more, I would say, natural way, in the right tools that everyone is used to use. If you are a developer, as I showed you in the earlier slide, they use the IDE, they use the GitHub areas. If you're an ops, you're using the APM and the logging tools. If you're shifting left observability, when something happens, the alerting happens in the APM, ops are good. Okay, this is the alert. Now the developers takes charge. They don't need to rely on the ops guys to give them telemetry, which usually they don't have. The developers have a dev native environment to troubleshoot in real time, in a proactive way with dynamic logging, as you see here, logging exactly what they need, when they need, and they really now own their application, their code, whether it's running in production, in serverless, Kubernetes, legacy, doesn't matter, but the developers are owning their own success, which is kind of a mind shift from where most of the organizations are today. If you go and ask today enterprises that are using and paying so much money to APM tools, what happens and what is the cycle when something breaks, they will say, yes, it's a lengthy cycle, because when something breaks, the APM gives an alert to the ops guys looking at the dashboard. The ops guys don't have the knowledge of what to do with the code. So the troubleshooting process begins, which is very long, up until it gets to the developers. Sometimes I'm hearing weeks. It takes them to understand and reproduce the issues and add more telemetry and build the full software from scratch. It's very, very inefficient. When you're able to shift left observability, you are really cutting, I would say, even more than half the time it takes. I have experienced minutes to few hours of reproducing and solving P1 and P2 production issues by clients that have implemented this shift left observability, developer observability, as we call it. And the way they benefit from such a new method is everything that I mentioned earlier. I mentioned Google Door, I mentioned observability cost, MTTR, cost optimization, time to market, and quality. So the way things are working, and let me just move to an environment that I can actually show you in real time what is happening. What you can see on the left screen is, and you can see here, the Java application, a very simple one that goes every half a second to the Wikipedia website and polls for an article. You can see here, every half a second, you are getting a new article title from Wikipedia. This application is running, it's still not running, but it's deployed in 2 remote environments, and it's running locally on my IntelliJ IDE in Java. Before I launch the application, I just want to show you that nothing is running. You see here in my Lightrun platform, you see here I have no agent running, okay, and I have no actions that you see here. This is an expired action from March, but you see I have no agents. What I'm going to do right now, I'm going to run and access 2 remote environments. One is an Oracle environment, and the other one is an AWS. And what I'm going to do right now, I'm going to run this exact replica of the Java application with my Lightrun dynamic instrumentation agent attached to it. Okay, I'm not touching the code. I'm just what is called, I'm just instrumenting. Okay, and the application is right now running in 2 agents, one in Oracle and one in AWS. And you see right now, every half a second, you see the skipping. I'm getting a new article on both deployments. And you see here on my plugin in IntelliJ, I see 2 agents, Oracle and AWS. And now you're also going to see them. I'm going to refresh my browser. You're going to see 2 environments, AWS and Oracle. Okay. And what I've just shown you is that as a developer, I'm living in a dream. Everything is good. The application is running in production and it's fine. But what is happening when something doesn't work? I'm getting an alert from ops, from the APM guys, that something is broken on both environments and I need to troubleshoot it. I have 2 ways of doing it with developer observability. You know, the logs, metrics, and traces, right? In Lightrun, we have logs, metrics, and snapshots, the virtual breakpoint. I will first put a virtual breakpoint, okay, what we call a snapshot. And here, I'm going to select the source. I'll go to AWS, okay, and I will ask for 3 breakpoints on this line so I can get the ability to investigate 3 different articles. Once the breakpoint was placed, the application is still running. It's not stopping, no matter which action I'm requesting from a telemetry data perspective. The application is not going to stop. I'm going to get the breakpoint. You see it here. I got a snapshot from production, and you see here I got another one, and I'll soon get another one. And you see here the title of the article, and you see the title of the article in the second snapshot and the third one. I didn't need to stop the application. I didn't need to do any full rerun of CI/CD. I was able to debug my application at runtime remotely, directly from the IDE. And you see it here. It's not. I'm not. It's exactly May 20th at 9:02 a.m. I live in the East Coast, so that's my current local time. I can also do something more exciting, and I can do what we call a conditional log. And here I'm going to see hello DevOps Pro Europe, okay? And I'm going to put a variable from the code RWA. I'm going to do it and pipe the log both to the std out, so you can see it in the console and in the IDE. I'm using AWS, okay? And you will soon see once I go to the IDE Lightrun console, okay? You see on the left, hello DevOps Pro Europe. Okay. Oh, I have a mistake here. You see, I didn't put the brackets here. Now it's going to be fixed. Okay. It just show you that it's live and I'm not stopping the application. You now see hello DevOps for Europe with the actual title of the live application running in production. I didn't need to stop it. You see it here, it's running on AWS, but as a developer, I don't really care where it's running. I do have here the ability to analyze and troubleshoot from my environment, which is awesome. And last but not least, as I mentioned earlier, the performance debugging is also something that is a pain. What I'm going to do right now, so we won't neglect Oracle. So I'm going to do something like that. I'll call it DevOps Pro Metrics. And here I'm going to analyze, and I can say to Prometheus and other environments, but I want to analyze how long it takes to run this specific block of code from line 33 to 37, again, at runtime in production without really stopping the application. And here you see on the left, right, DevOps Pro metrics. I'm already collecting timings, okay, metrics from the environment. And here soon, when I go to the TikTok, because that's how we call it, you're already going to see that I'm building a graph of performance, so I can analyze the peak environments. I can analyze them here in the IDE or from the Prometheus and other metrics related environments that I'm using. But the most important thing is that I'm collecting data at runtime from production environments without really stopping the application. And you can see here in the dashboard, when I'm clicking on actions, you can see here exactly that I've added metrics, dynamic logs, and virtual breakpoints during the application at runtime without really stopping it. So it's all managed and fully governed within the platform. And if I need, again, to connect my metrics and logs and everything to other provider, connecting ops and devs, as I mentioned in my session, I can easily integrate to Prometheus, Instana, Dynatrace, Splunk. So it's all a better together, if you like, approach. So everyone can continuously work between development and operations, but in a more streamlined and efficient way. With that, I've done the demo, and I want to leave just a couple of minutes for anyone online. If you have any questions, I'll just stop my screen so I can see the chat. And let's see if there are any questions. Okay. Okay, I see that there are a few questions. I will read, for those of you who are not able to see because it's a private chat, I will just read the few questions that are coming in. The first one, today at another session, a statement was made that the lack of local testing is a big problem for the organizations, where you mentioned it is a problem with some aspects. What do you think the impossibility of testing something locally is due to the organization or the tools used? It's a great question. As an ex-director of QA and an author of testing books, I usually don't like to blame, tools or organizations or testing. Quality is the responsibility of everyone. But I would actually say that it's the nature of the applications. If in the past you had much more time for deployment and for testing, nowadays I will tell you from my experience at Lighton, we release a new software version every 2 weeks. Okay, in these 2 weeks, both the development team and the testing team and the documentation guys and the product, everyone needs to work in a very coordinated way. And we're building cloud product, right? You have seen the product demo, right? It's fully SaaS. So being able to locally also build new tests for new features like actions and logs and everything that I've shown you, and also build the feature itself is very, very challenging. So I think that there has been a change over the past few years with the modernization of software, where time is very short for both developers. I'm not blaming developers or testers. The time is short on both the developers and the testers, which means that they need to think a bit outside of the box and kind of readapt the processes to what is really happening, because you already know today that in 2 weeks you have a release. You already know that this release is going to be deployed with X amount of feature flags across 10 different clients or 100 different clients. So you need to have kind of an automated setup environment with a baseline that is matching the previous version, on top of which you add your new test case that you added, plus regressions, because things happen, right? So it's all a new automated mindset and techniques that developers and testers needs to come up with. And things like I've just demonstrated, Lighton, what we call the dog fooding, my developers are using their product sometimes to debug issues that are coming from our production customers. When something happens, no one is perfect, right? But when you have a tool that allows you to shorten the time that you need to recreate every complex scenario, you're in a very you're in a better position to address issues that are happening in production. So I don't think that it's impossible to test. I think that it's just harder, and organizations need to optimize the way that they are doing that. The next question was, how much is light run affecting performance for high load system? So that's a great question, and we have actually metrics that we can share. I won't do here. I'm not going to promote light run. Here I can only tell you based on technology, right? That as you have seen, up until the light run agent is running, nothing happens. And when it's running, it's lazy. It's not doing anything. It only waits for the server to ask for an action. So if everything is working in production, you don't need anything, there is zero impact, not near zero. It's actually zero impact. When there is a need for a snapshot or for dynamic log, it takes you like a very, very microsecond, because we are very, very fast, very optimized. So we only ask you to debug and request telemetry when things are not working. So when everything is fine, you don't need to do anything, but you're prepared for when things are actually broken, and then you can add these telemetry requests or actions, and you're going to use them. But the payload and the impact is very, very negligible. The next question is, what should be the first step to move to ODD, observability-driven development? So the first step is to identify and acknowledge the pains where you have them. And as I mentioned, there are different use cases. Some of them are very generic, just troubleshooting my Kubernetes cluster, or just troubleshooting serverless. There can be specific CVE troubleshooting. There can be things around log optimization. There can be things around CI/CD, which is unstable. So the first step is, and by the way, I'm already seeing many organizations starting to move toward platform engineering. So if you're already looking at a new mindset because something isn't working well for you, and platform engineering is a good sign of a reshuffling of your tool set. This is a good step or a good sign for you to look at, okay, how is my observability strategy looking today? What is my metrics? What are my metrics for MTTR, for time to deploy, okay, for failure rates, right? If you have these metrics and you have the goals or objectives to what you want to improve, you already know what will be the first step. The first step is, of course, moving to observability-driven development means that you are trying to not break the silos, to actually connect the silos between dev and ops. You're trying to fix a broken channel between your operations. And the first step is, yes, using a developer observability platform, right? This is a growing technology today, which was built by developers for developers because of the pains that everyone is talking about, and I've demonstrated them during the session. So yes, mixing and matching technologies. Many organizations today have 10 to 12 tools within their CI/CD pipeline. Not all of them are very optimized, and not every tool is working great. For that, you need to think, okay, how do I merge and manage multiple tools in the observability tool chain that actually moves the needle and improves my MTTR, my developer productivity, my developer experience? No developers want to spend days and weeks on just troubleshooting issues if you can do it much faster. And last question, because we are very short to the end, and I appreciate everyone that was asking these questions. Thank you so much. What if there are multiple instances of the same application, you don't know from which instance exactly the breakpoint is going to be hit? It's a great question. For that, we have, obviously, for each deployment, you're going to have an agent, a light run agent, and you're going to use tagging, okay? Like you use feature flag, you can use tags, and with the tagging, you are going to put a tag on a snapshot or a log, and the ones that jumps to you, you know that it's coming from this environment. You can add conditional snapshots, dynamic and conditional logs and metrics, so you are easily getting all the telemetry from the exact point of the failure directly, as I've shown, to your IDE, to the IntelliJ, VS Code, PyCharm, and the likes, so you can troubleshoot in runtime as fast as you can. With that, I am exactly on time. Thank you everyone for being in this session and asking the questions. If you have any questions to either me or about Lightrun, feel free to reach out to me on LinkedIn or Slack or WhatsApp. And if you want to just try it yourself, just go to playground.lightrun.com. It's free. You can use Wordle implementation that is deployed on Lightrun website and troubleshoot it and see how it actually works. So you get my word, and it's not just I invent things. You can play with it firsthand. With that, thank you so much, and I hope to see you in my next session. Thank you so much.